Work. The meaning of the word work is quite different in the common language and in physics. In general, work implies mental or physical activity. While studying, we do mental work. When walking, running or playing, we do physical work. Such types of work can't be measured. So, the work becomes a non-physical quantity. In physics, a physical quantity should be measurable. Therefore, work is defined in such a way that it becomes measurable and hence a physical quantity. For example, when we push a cart, we do work. It can be noticed that greater the displacement, greater is the work done. Similarly, greater the force, greater is the work done. This shows that the work done depends upon the amount of force and the amount of displacement. Hence, work is done on an object only when a force is applied on it, and it is displaced under the effect of force. It is measured as the product of force and the displacement in the direction of force. Here, it is assumed that during the whole displacement, the force remains constant. When a force is exerted on an object at an angle to the horizontal, only a part of the force contributes to a horizontal displacement, that is, the horizontal component of the force, because this component of the force acts along the direction of the motion of the object. In other words, the horizontal component of the force does the work, whereas the perpendicular component of the force never does any work on the object. In general, when the force is applied at an angle to the displacement, then the work done is the product of component of the force in the direction of displacement and the displacement itself. Work is a scalar quantity. In SI units, work is measured in joules. Named after the famous British physicist James Prescott Joule. 1 joule of work is done if a force of 1 Newton is able to displace an object by 1 meter. In general, any unit of force multiplied by any unit of displacement gives the unit of work. Similarly, in CGS system, 1 erg of work is done if a force of 1 dyne is able to displace an object by 1 centimeter. It can be noticed that 1 joule is equal to 10 to the power 7 ergs. When we push an object and the object moves in the direction of force, then the work done on the object is positive. Further, if the object is forced to move on a rough surface, the friction opposes the motion. That is, the force and the displacement are in opposite direction, and thereby the friction force does the negative work on the cart. And the net work done on the cart is the algebraic sum of work done by each force separately. Hence, work done is the product of force and displacement when force is in the direction of displacement. If the applied force and the opposing force, that is, frictional force are equal, the net work done is 0. Further, if the body moves under the action of opposing force, such as gravitational force, net work done on the body becomes negative. In other words, this is the work done by the body. Let's see some interesting situations. When a person holding a suitcase in his hand stands at one place, also does not work on the suitcase. However, one can become tired in doing so because the individual cell in our muscles contract and expand continuously. Hence, our muscles are doing mechanical work even though we are at rest. While lifting a load, work done by the applied force is positive and work done by the gravitational force is negative. Now look at an interesting situation. A man is walking with a load on his head. The only force acting on the load is gravitation in vertically downward direction. The direction of displacement is along the ground, that is, horizontal. Thus, the directions of application of force and displacement are at an angle of 90 degrees with each other. No work is done in this case. When a porter moves a railway platform with a heavy load on his head, he exerts a vertically upward force on the load. But the displacement of the load is in horizontal direction. Since there is no displacement of the load in vertical direction, hence the work done by the force exerted by the porter on the load is 0. But when the porter climbs up on the stairs, he does work on the load as the displacement is in upward direction. On the other hand, when the porter comes down on the stairs, he does negative work on the load as the displacement is in downward direction and the force is in upward direction. In other words, a positive work is done by the load. Let's relook the situations to analyze the work done by the gravitational force. When the porter moves on the railway platform with a heavy load on his head, the gravitation force, that is, the weight of the load, acts in the downward direction and the displacement of the load is in horizontal direction. Again, in this situation, the work done on the load is 0. But when the porter climbs up on the stairs, gravitation force does a negative work on the load as the displacement is in upward direction. In other words, a positive work is done by the load. When the porter comes down on the stairs, the gravitational force does positive work on the load, as the displacement is also in the downward direction. In other words, negative work is done by the load. A force shifts a 50 kg block through a distance of 10 meters while performing 60 joules of work. Calculate the magnitude of the force. Since work done is the product of force and the displacement, this gives force equal to 6 Newton. In the next problem, a force of 100 Newton is applied to an object of mass 15 kg to move it through a distance of 5 meters in the direction of the applied force. Now, calculate the amount of work done. Using the relation for work done, it comes out to be 500 joule. Let's say another problem. A boy pulls a block on a horizontal surface by applying a force of 6 Newton at an angle of 30 degrees with the horizontal. Measure the work done by the force in displacing the block through 3 meters. Since the work done is the product of force in the direction of displacement and the displacement itself, this gives the work done as 9 under root 3 joules. In the next problem, a 1 kilogram ball is thrown up with a speed of 9.9 meters per second. Measure the work done by the weight in 1 second. To measure the work done by the weight, we need the applied force, that is, the weight of the ball and the displacement. Here, the weight of the ball is 9.8 Newton and the displacement can be measured using the displacement time relation as shown. Since the force and the displacement are in opposite direction, hence the work done by the weight in 1 second is minus 49 joule.